Hello ladies and gentlemen, my name is Nikolai, this is Christian. Welcome to our science lab presentation. We hope you're going to enjoy it. In this presentation we would like to tell you guys about why we chose this topic, some facts and knowledge about microbes, our test and work process, and in the end some results and conclusion.
So why did we choose this topic? We chose this topic because we thought doing microbiology would be fun, and we wanted to know more about why people get sick and what microbes we're dealing with every day. We wanted to test different places in our environment to test if there are any harmful microbes there. So to test this, we had to grow and identify the bacteria and fungi. To do that, we had to make agar plates, take samples of the places we wanted to test, make slides, and then identify the microbes. We hope to learn more about microbes, what they are and where they can be found and how dangerous they are, and then a little about the consequences of not being hygienic. In places we touch, we expect to find skin bacteria like Staphylococcus, Micrococcus, Dermabacter, and others. In the bathroom, we expected skin bacteria and intestinal bacteria like E. coli. In the gym, we expect skin and sweat bacteria, but hope not to find any bacteria at all, because then we know the cleaning agents we use for cleaning the machines after use actually work. But before we could get started on testing all these things, we needed some research.
Microbes. Microbes are everywhere in our daily life. They are on you, around you, and inside you. Microbes are microscopic, and therefore they cannot be seen with the bare eye. There are microbes that keep your body healthy and help your body to stay healthy, but there are also microbes that try to make you ill or even kill you. Some species of microbe can consume many things that animals can't, such as non-organic things like metals, rocks and other minerals. These microbes are usually classified as extremophiles and survive best in harsh conditions like burning deserts, on freezing mountains or underground acidic caves. Some can even feed on predation. Microbes or microorganisms are unicellular or multicellular. They can form colonies or they can live alone. Microbes are the most widespread living thing on the earth. They can be found virtually anywhere on earth. Microbes can be broken down into 4 separate different groups: bacteria, virus, fungi, and parasites. We will only be telling about fungus and bacteria because that was what we were able to find in our experiment. Bacteria. Bacteria have been alive for 3.5 billion years. That makes them the oldest living thing on the earth. Bacteria are unicellular, prokaryotic microorganisms that are everywhere. There are 3 common or main shapes of bacteria: a spherical shape called coccus, a spiral shape called spirillum, but is also known as spiralia or spirillus. Last but not least, we got a rod shape called bacillus. From there, they can be divided into 2 other groups: gram-negative and gram-positive. If a bacteria is gram-positive, its cell wall is thick, dry, and stronger than a gram-negative.
Fungi. Fungi is a microbe type. They can be unicellular, multicellular, and dimorphic. They're eukaryotic, meaning they have a true nucleus. They get their energy from consuming things like dead matter or living beings, so they're heterotrophic. They can both reproduce sexually and asexually, and mushrooms like those you eat from maybe the forest are actually reproductive structures made of haploid spore cells of some species of fungi. Fungi like to form good relationships, so if you maybe have a fungi and a tree. The tree needs water, so the fungi will give the tree water, and also the other way around. So they support each other. But fungi can also be bad. They can cause infections, and these infections can be treated with antibiotics. And they can grow without the presence of air or light. The effects of microbes can both be good and bad, of course. But not only bad as many may think. Actually, we probably wouldn't be able to live without fungi and bacteria. Bacteria play a huge role in our digestion. Without them, we wouldn't be able to digest certain things. Fungi helps out a lot in the carbon cycle. They decompose dead matter much faster than if they weren't there. They're also used in many industries, such as antibiotics. The first antibiotic was a penicillin. Many lives have been saved by penicillin, and you've probably used them yourself too. But of course there are also bad things about microbes. They can make you sick, and even some can kill you. These are usually classified as pathogens. Pathogen in Greek means disease causer. Although they can be harmful to you, you also actually need pathogens. If you don't get enough pathogens into your system, your immune system would get really weak, and you might even not be able to cure yourself for a cold.
And we got some facts about microbes. One, all of the bacteria in the human body actually weighs about 4 pounds, and there are actually more bacteria cells than human cells in your body. An average disk have 400 times more bacteria than a toilet seat. 3. It is a good idea to take a bit of dark chocolate because it actually helps your mouth to break down the bacteria and protects against tooth decay. 4. Did you also know that there are more bacteria in your mouth than there are people in the whole world? And even if your mouth is clean, there are still between 1,000 and 100,000 bacteria on each tooth. 5. The fungus is actually closer to being an animal cell than a plant cell. 6. Your mobile phone contains more bacteria than a toilet flush button. And now when we heard a little about microbes, let's talk about our experiment and how we did it. We started the test by making the agar plates. That part our wonderful teacher Mihaela helped us with. First we started by heating the agar bud in a microwave. Then we shook it very well so all the agar was liquid. Then we waited until the agar was cold enough for us to hold it. At that temperature the agar should be ready to be poured onto the agar plates. When we have poured the agar, we have caused it near fire to prevent any unwanted airborne bacteria to start growing on the agar. Then we started taking our tests. These tests were done with sterilized cotton buds dipped in salt water. To take the samples, we rubbed the wet cotton buds on the surface of the area we wanted to test for microbes. Then we gently rubbed the cotton bud on the agar in a square pattern to spread the bacteria out on the plate. We started by making a control test where we only have dipped the cotton buds in salt water. After that we went out to test the rest. These tests would be conducted over several days and with traditional methods of testing for microbes. We tested the following places plus the control test: door handles, table surface, pens, computer keyboards, toilet flush button, toilet seat, gym machines, gym free weight, gym treadmill, mobile phone, a handball were unwashed and a handball washed, water dispenser and school fruits. When we had taken the samples of the different places, we put the agar plate in the heat incubation chamber. From Friday to Tuesday. Tuesday we brought them out and started preparing our slides.
So first we had to take pictures of them, like these, to document what we had grown. Then we had to clean slides with fire and paper to make them clean. And now we have a little video to demonstrate how we gram stained, to test for if they were gram positive or negative. So here we have our slides. Now I transfer some of the bacteria, I think it's E. coli, over onto the slides. Now I put a few drops of water onto the slide to make it stay there. And now I dry it up again. This is our primary color. This is for gram-positive bacteria. It's called crystal violet. And it has to sink in for a minute and then be washed off with the normal tap water. Then we put on iodine. This is to help the crystal violet bind to the gram-positive cells. It also has to sink in for a minute and then be washed off with ethanol. And now we have to put on our secondary color, saffron in solution. This is for gram-negative bacteria. This also has to wait for a minute and then be washed off. Now this slide is done, and now we're going on to make another type of slide for testing for fungi. So again, we transfer some of the, I think it's fungi cells now, yeah, over to the slide, and then we have to put on the color methylene blue. This will color the fungi cells blue. And now the slide is done too.
Now we have shown you how we did the experiment, and we hope you are excited to hear our results. When we have made the sample size and were looking under the microscope, we first found a lot of fungi. Then we started thinking about what was that yellow, creamy and shiny bacteria that had contaminated nearly all the agar plates. Then we made a slide where we only tested one colony of that exact type. The results showed that it was gram-negative, and we started thinking about if it was E. coli or not. It had the smell of feces that we expected to have. The colonies looked like those pictures we found on the internet with E. coli. And it was gram-negative. From all those things they had in common, we concluded that it was E. coli. Then we started counting the numbers of colonies of E. coli compared to the number of colonies in total, including fungus. What we found out was shocking. Out of 736 colonies that we have grown, that is just roughly, as some of the bacteria were very large and grown together in rows. But around 300 of them were E. coli. That is nearly 40%. This is also shown on our pie chart. We also found out that the samples we had taken from the fruits weren't contaminated with E. coli or any other form of bacteria, but with fungi. Another thing that we had tested was the difference between unwashed and well-washed tanks. The difference in the amount of E. coli bacteria was fantastic. It went from 40 colonies to 6 colonies after being washed well.
And now you might be thinking, what is E. coli? E. coli or Escherichia coli is a gram-negative bacteria species with both helpful and harmful strains. It is one of the most prominent bacteria of our gut and also many humans. It helps keep out other dangerous bacteria. It was discovered in 1885 by a German bacteriologist named Theodor Escherich, so it was named after him. The harmful strains are called Shiga toxin-producing E. coli due to a toxin they produce. Symptoms of E. coli infection are diarrhea, abdominal pain and dehydration, and in severe cases it can even lead to kidney failure. E. coli is a very common cause of intestinal infections. Out from our results of the Petri dishes where we tested for unwashed and a washed hand, we could easily conclude that washing your hands really helps. The presence of E. coli colonies dropped by 34 colonies, and the total fell by 10. Another very easy conclusion to make is that E. coli is nearly everywhere. One of the results that surprised us a bit was the one with the fruits. It had only fungi on it, and that makes actually good sense. Because fruits, they have a lot of sugar, and fungi, they thrive off sugar. So of course the fungi will start to grow on the sugar, on the fruit. The fungi will start to deteriorate the fruit and grow into a mold. This is a good reason why you should eat your wash your fruit before eating it to get rid of the fungi.
If you ever been to the gym, you should know that you always have to clean the machines with ethanol after use. One of the things we wanted to test if the cleaning actually works, and we will conclude that it actually does. We made 3 tests of different equipment in the gym. 1 machine, 1 treadmill, and 1 free weight. The result of the machine were good and showed that the small area we did the sample on was very clean. Only 8 small colonies grew on that sample. That is the cleanest one except of the control. And that is incredible compared to how disgusting sweat is and how much sweat we expose every day. The area that we sampled is an area of the machine that is nearly impossible to miss, so we would be sure to get the right result and we got the results that we hoped for. The cleaning of the machine does actually clean them. The other 2 samples didn't show the same result. The free weights aren't usually clean and therefore they can be very contaminated, being the one with the 3rd most colonies on it. The treadmill wasn't clean either. We also sampled the treadmill on some of the places that you might not think of cleaning. But from the sample we can conclude that it really helps to clean the machines after use. And now how you can protect yourself in maybe the best and easiest way. If you just remember to wash your hands after you come from school or work, and always wash your hands before you have a good meal. Sometimes it is a good idea to clean your mobile phone, your computer keyboard, your consoles that you probably use every day. And you could take a shower every single day to get a clean body. And these are just some of the ways that you could keep